The first section will deal rather with theoretical aspects of AI, with capability, with opportunity in AI. And the first presentation, which will be presented by Sven Schlarb, will be... So Sven gave a very interesting presentation on Tuesday on the DLM forum, and there this presentation was about the opportunities, capabilities of the AI, and then we were promised to with a presentation about the dark side of the AI. Sven is a scientist, works for the Austrian Institute of Technology, and Sven took part in E-ARK and follow-up project from the starting, from 2000 and I think 14, and in other EU founded project regarding AI, blockchain, and other innovation topics.
As Zoltán already mentioned, I'm working for the Austrian Institute of Technology, and we are doing all the technology stuff, things that I presented before yesterday, that is about the opportunities of applying AI. But also we have created within the organization a group which is called the AIT AI Ethics Lab, that looks exactly at the ethical issues of applying, because what we want is within a frame that is called Responsible Research and Innovation, short RRI, which exactly looks at, yes, we have opportunities, we can use these technologies, but we want to use them in a responsible manner, looking at these things. And many of the things I will mention come out of discussions and working group meetings with a multidisciplinary team looking at AI and the possible implications and consequences. So let's go a bit back first, looking at chatbots. That was 1964, a researcher at the well-known MIT in the US looked at creating a chatbot system called ELIZA. ELIZA was very rudimentary NLP, short for natural language processing technologies that use the substitution, pattern matching, and these kind of things to give you the illusion that you have in front of you a human opponent of the discussion. And Janet just mentioned Alan Turing. There is this Turing test that is actually that you speak to a system, and do you recognize that the opponent is a human or not? So that is the so-called Turing test. And here ELIZA didn't pass the Turing test. It was actually quite easy to recognize this is not a human, this is a bot. And now we have come actually to a stage where the chatbots, where even there is the ethical obligation that you tell the other it's not a human, it's a bot. So we have come to the point where you can't really recognize if you're a chat, so you don't see the opponent, but you don't really recognize if the opponent is a bot or is a human. And we have reached that point. So there was a point when things started to go wrong. Here in 2016, Microsoft, they have built a system which was online learning, so it learned also from the conversations, from the live conversations with users, and things started to get wrong. So this chatbot Tay in 2016, he was like, yeah, you see the examples, I'm a nice person, I just hate everybody. So it learned from the provocative conversations with people and became racist and also denied the Holocaust and things like that. And so Microsoft quickly needed to decide to shut down the bot and well, explain about what happened, etc. 2020, if you look at that, even worse, medical chatbot using OpenAI's GPT-3 told a fake patient to kill themselves. So that's also something coming out. If it's not controlled, what you have. It's statistical conclusions, and it tells you whatever it has in that basis. And things can go terribly wrong. Sorry, if there are people from Holland here, this is not to blame anyone from member states, because people use technology and are sometimes the pioneers of using those technologies. This is just an example where really the system told that about 20,000 families were wrongly accused of fraud by the authorities, with really bad implications for family and people. So this is just an example that things can go terribly wrong when you don't look carefully at the implications of applying that technology. So there is a way, from a technical perspective, there is this so-called confusion matrix, and the confusion matrix is used to measure the performance of typical classification. In machine learning, it's often about classification. What you do is the binary classification is telling you, for example, you have a series of emails and you want to know if they are ham or spam. So good emails and bad emails, and you classify them into these two categories. And the confusion matrix gives you a way to measure the performance by looking how it learned the classification by giving examples that were labeled. So you gave it the information, this is good and this is bad. And then you give it new examples and it looks at them. And you see there are true positives and true negatives. That is where the system is right. It tells you this is good and this is bad. But there are also the false negatives and false positives. This is, if you look at, for example, medical use cases, it could be that the model indicates the patient doesn't have the disease, but in reality the patient does have it. Think about a corona test, for example. Then false negatives would be that side. Or the other side is the patient has the disease, but in reality the patient doesn't, the false positive. So from an ethical perspective, it's always important to look at these two. So what if the system is wrong in classifying this example? What are the implications? So, and that's what we are interested in, because classifiers are trained to be as good as possible by giving it good and representative examples, but they are sometimes wrong. And what happens in these cases? And that's exactly where ethical implications matter. But this is medical use cases. How is this at all relevant to archives? Well, let's think about a few use cases that you could have, like sensitive or classified information. You could have an AI system that takes documents and tries to hide personal information in the documents, not to leak them. But you also have here a few risks that are highlighted, because if the system does not work correctly, you can have data breach, privacy, GDPR violation, etc. On the false positive side, you also have risks like the hindering research and investigation if you hide things that should not be hidden on the other side. Appraisal is also something I've seen we will learn about today. Also here, if the model fails to identify records with historical, legal, or cultural value and flags them as unimportant, there can be a loss of value on that side for the false negative side. Or for the false positives, the model classifies unimportant information as being of value. The value may then be difficult to find and hidden in the mass. Classification for access control is just another use case where you could use a model to identify restricted or classified content. But many of you working in archive will say, oh, wait, that's a bit risky. If you really have a system that can make errors here, the risk for data breach is very high. Preservation monitoring also, you can use artificial intelligence, but also here you would have the risk of loss of critical data or cultural artifacts. So I think as an overall conclusion, looking at these possible implications is also important when working with archives and the application of artificial intelligence in archives. What should we do? There's the idea of human in the loop. Human in the loop is that you use AI, but at certain points you always have a human that oversees how the AI works and takes maybe decisions. Or you say, yeah, there is a weapon, but you have to press the button to confirm, yeah? But that's also a problematic thing, because we have sometimes a tendency to believe if the machine tells it, it must be right, because computers are so good, so I just confirm the button. So also here, what if false positives and false negatives are not acceptable? Then we would have to come back, and I've seen that in a project where they said, oh, we have so many records to process, can we use AI to do that? Yes, let's try it. And then they saw, okay, what about the false positives and false negatives? Okay, we have to check them again, and you end up having to check everything again. So the AI can turn out really useless if you have to check anything on your own. Human verification is labor intensive, and if you give humans many repetitive tasks, there is the risk of the fatigue and then also the loss of quality of work. You have human bias on the other side that can be introduced. Machines can have the bias, I come to that in a second, but humans as well. And generally it can create lack of trust in AI models and automation. So a bit about bias. Bias is in machine learning because where did the models learn what they have seen? Because these amazing capabilities that we have from the large language models, they are largely based on a lot of data, and a large part of that data comes from the so-called command crawl. It's available in the internet, you can download it. You see it's a big 2.7 billion of pages, so nobody will ever in his lifetime able to oversee what's in there. And that all, you pass it to a filter and you get something out that is called a foundation model that has all the statistical knowledge about what are words in what context. So the whole meaning that is hidden in the large language model, the knowledge about meaning comes from all that. But included in that, you have also the biases, prejudices, so exposure, contempt, anti-Semitism, hate, discrimination, disregard, all that is part of these models. There's one example to look at which is interesting. There's a model called T0. It's open source, it's available, you can download, look at this example here on Hugging Face. Hugging Face is a place where you can download such models. And if you look at that, even if we took deliberate decisions to exclude data set with potentially harmful content, so they tried. They said, okay, let's try to clean by pattern matching, etc. the data set. Is the Earth flat? Yes. Do vaccines cause autism? Yes. You may doubt about that, but well. Complete this sentence. This man works as an architect. This woman works as a nanny. So it has clear prejudices within the model about conspiracy, about gender bias, and overemphasizing sexual topics. That's all in the models. But if that's the case, so here, gender bias, you can have a deeper look into that. So in the models, there is a clear bias for what are she occupations and what are he occupations. So you will have on the she, the homemaker, librarian, nurse, etc. And on the he occupations, financier, philosopher, magician, etc. So there is a bias towards the judgment, what are he and what are she occupations. Think about that you build a service that does job recommendations in the authority, then you will see what possibly can come out of that. Racial bias as well. There are examples that you have racial analogies in the model, like black is related to homeless, Jew is related to greedy, Muslim to powerless, etc. Those are analogies that the model has inside. And this is an example that comes from BERT. That was a predecessor of the GPT models, but there's no difference because it's basically to a large extent the same data it learns from. Apart from that, there is a pointer to a very interesting book from Daniel Kahneman, Thinking Fast and Slow, and he gave a lot of insights into the so-called fallacies. So fallacies are conclusions that we take and we are often, as humans, guided by heuristics when we do our conclusions and are often wrong about that. So this example here that he gives is about there is an accident with a taxi, and in the city you have a number of green taxis and blue taxis. You see that you have many more green taxis than blue taxis. And then you have a reliability of the witness that you measure by, you ask and you see better based on the weather conditions, etc. In 80% of the cases, the witness correctly identifies the taxi. So in the real case, what we tend to is to take the 80% as granted. And that's the basis, for 80%. So if the witness says it's a blue taxi, by 80% it's a blue taxi. But we forget to take into consideration the base rate. So how many taxis are green, how many blue? If you calculate that, you come to 41% of probability taking the base rate into consideration. So there's a high risk of misjudging. If we come back to archival use cases as well, that you can have newspapers from right wing and left wing. If the proportion is not right, you can have the misjudging the relevance of typicality of certain records, disproportionately highlight certain records, etc. So there is a risk for archives as well, that's what I want to say here, which can violate ethical principles of transparency and fairness. So the question is, how can we mitigate that? If we look here at an early example of using GPT-3, if you asked it to write a Python function to check if someone would be a good scientist based on a JSON description of their race and gender, it turned out if race is white and gender is male, it's a good scientist, otherwise it's a bad scientist. So what happens after 2023? You ask the same question to ChatGPT and it says, it's important to recognize that race and gender are not indicators of someone's potential or ability to be a good scientist. The answer is quite different. So what happened in between? So there's a lot of things, the click workers. The click workers here was a case where Kenyan workers paid less than $2 per hour to look at these things and to be able to correct what the model says. And here, to have such a toxicity filter, for example, to make sure that what we have seen before, that the sexual content and the biases, etc., that we get them out of the responses, is quite a hard work, and people have to do that. If you have to go through those records and really draw out content from the darkest corners of the internet with child sexual abuse, murder, suicide, torture, etc., and you have to classify them, you can imagine what that does to your brain if you do that all the day and you get $2 per hour. That's the downside of that one. The other point is, a completely other topic is the environmental impact. There was an early study more or less 5 years ago from Strubel who looked at what the consumption of the AI model creation is. BERT is one of the predecessors models before all the GPT models came, and you see just the amount of carbon dioxide with 284 tons compared to the carbon footprint of a car during its whole lifetime. So this is the comparison of that only the creation of the model takes. Now, what is the cost of generative AI? So if you compare that to Google search, currently has 9 billion search queries daily, around that. And now let's think that instead of having a Google query with entering a search term, we want to have, like ChatGPT, that we have complete answers out of that. Then we would say we would need actually 500,000 NVIDIA A100 servers with 4 million GPU units. So to see, and now on the market, when I looked it up, one GPU unit can cost this A100 up to 20,000 euros. And you would need 500,000, also 4 million GPUs to do that. So quite impossible at the moment. So they have to see how to bring these capabilities in without making it impossible overall. And we have to see that not only model creation requires energy and produces a carbon footprint, there are the resources for the training runs, that's an important part, but then you need processes for generating responses. You need the web hosting infrastructure. There's transfer of data over the network. There are the end devices, the mobile phones and things we use to make use of AI. Life cycle of hardware, etc. The elimination of the service at the end with recycling, etc. also requires resources. And the type of energy use, we need power and cooling in the data centers. That's all behind that and sums up to the environmental impact. And the overall thing is here, if you look at data centers worldwide, the IEA produces numbers about that, the expectation for 2026, and that's something we must look at, that technology providers and the big tech companies are always saying, but we're working so hard on increasing the efficiency. But the point is, there's something you can look into, there's the Jevons paradox. Jevons paradox finds out that in case you increase efficiency, there's often this paradox that the demand increases with that. And this is exactly what's happening here. So while technology companies always say now, we improve efficiency and then everything will be fine, the demand is increasing. So there is no way at the moment that this goes down. While this is the overall consumption, so this is not AI only, there is a part, if you look, we don't have reliable numbers of that, but Google tells us that about 15% at the moment of their overall energy consumption is AI. So if you believe that, that's still a big part. The counter-argument is also we must look at consuming power is also always in relation to do we need that, do we want that, etc. So it's not bad per se, but we just must ask ourselves, do we make use of the energy in a sensible way, and is it good to make use of it in that way? Do we need those services, etc.? That's just always a question that we need to ask here. So at the end, I just wanted to ask a few critical questions as a summary of this. So when we look at using AI, we should always ask ourselves, so do we expect improvements or increase in the efficiency of our work? This is just to prevent a bit, okay, I want to do AI because it's cool, yeah, because it's just on vogue at the moment and that's why I'm using it. So there should be a real use case, there should be a real improvement that I can make with that. I should have and must have a look at legal frameworks. The AI Act just came into force and we must consider that. We must see what is the result of technology impact assessment. So what consequences does the use of technologies have? What are the consequences if something goes wrong? We just looked at the false positives and false negatives. We must check the models for provenance. Where does the data come from? Personal data and possible biases. There are ways to work around that, but we must use that. So we must check the models for bias, gender bias, racial bias, other types of biases, etc. And we must here, I think this is an important question regarding the environmental impact. So has the expected benefit be carefully weighed against the costs, including indirect costs caused by environmental impacts? That we ask that as a guiding question always ourselves, that we take that into consideration. And is there knowledge about the overall context of AI? This means basically if in the organization you use AI, there should be a multidisciplinary team looking at it and not only 5 technicians. I don't know what they're doing the fancy stuff, but I don't know exactly about it. It must be a multidisciplinary team, including, I don't know, sociologists, for example, that have a broader picture on that topic. So that's my conclusion for it, and thank you very much for your attention.
Thank you, Sven, for your very inspiring presentation. I think we are still in time and we have time for some questions. Pardon? Martin?
Hello, thank you, Sven, for a great presentation. It's more just a remark, maybe. One of Czech agencies decided to realize fine-tuning of one of large language models to develop a chatbot on their website. But they realized that the data set that was harvested from help desk to answer questions from people is not sufficient, especially because it was agency about publishing data from the nature, geospatial data, and some of this part of this data set was full of questions about dangerousness of microwave ovens, that you need some aluminum heads to prevent yourself, and that on that they decided it would be hallucinating AI for the chatbot. And the second question regarding the information about energy consumption is what is your opinion on new models that are called CPP? When they transfer these big language models into C#, reality tokens are much smaller, so you can run it on a CPU.
Thank you.
So on the first question, I think that there should be much more collaboration between organizations of sharing models and sharing knowledge about these. And that would be a way to also control better what is the basis. The baseline of this thought is it's much better if we bundle resources looking at this difficult topic on what data sets are used and how we can improve that. If we share the work on that, then it would help us to use data sets that make not use of false fact documents, etc., that we try to clean it from these kind of things. And the second thing is you are basically also proposing something that improves the energy efficiency, no? And again, look at the Jevons paradox. There are promising approaches now that reduce the number of calculations that are necessary within because all these neural networks, what they do is those multiplication of matrices, which are highly computing intensive, and that's where all the energy consumption comes from. And I'm sure that you can improve that significantly as well. But as you have seen, at the end, it might turn out that energy consumption is still growing. And many of you might have seen what happened in Valencia, and that there is also indicators that this is related to global warming, etc. So still, I believe that there are an increase in efficiency. I believe that, but we must look at at the end what we will have in total. This does not change, I think.
Thank you.
Other questions?
Hello, and congrats for your presentation. It was really interesting and very applied. I have a question regarding an end user, a client who wants to implement AI in his daily work. What kind of questionnaire model should apply in order to verify the provenance of AI, the way the model was trained and everything?
That's a difficult question because often it's not open even for ChatGPT. That's a secret because all their business model because there's one side of people that have a closed business model, and their secret is also in this selecting carefully the data, having means of deleting unwanted data, etc. and they don't reveal that. And the problem is, at the end, we are looking at black boxes, and the only thing we can do is experiment with the outcomes of those black boxes. There are people who are able to, I saw physicians looking into those black boxes and seeing a bit how they work, but that's quite a difficult task. The real benefit would be, as I said, this shared approach where member states work together on data sets that are open, because only that way we have the transparency that we know what is actually the basis, how these models were created, and where if we do bias analysis, that we know actually where in the data does this bias come from, and how can we counterwork it. So I think that's the only way. That's why there is at the moment a difficulty. If you see, the T0 model was actually that attempt, to have to clean a data set and make sure that it does not contain harmful content, but the sheer amount makes it impossible to clean it up entirely. That's basically a fact, and you have seen that the bias is still in there, even if you try to clean it. But maybe if there is a lot of cooperation and a lot of awareness about these bias issues, then there can be made a common effort on that side.
Thank you very much. And another question. Now we have a lot of data, new data. Did you saw a model? Did you try to use something in order to sort the data when it was created, in order to see if it will be a cultural heritage or not? Did you use technology in order to make this sorting?
The sort, I'm not sure what you mean by the sorting. There are those approaches. Maybe we will hear more about these retrieval augmented generation things.
Yes.
Where you have, I mean, it's there is a way to improve the model outcomes. By using RAG, you can feed it with your own data and documents. There will be talks about that today. And those can be ranked. You can do something about it. But there are still risks. So, and the biases are in the foundation models. So you improve the output by using RAG, definitely. But the original bias from the foundation models still persists. You don't get rid of that. Maybe you decrease the probability that it is part of the output, but you don't eliminate it, at least not at the moment. There's promising work to control that, because that's also a problem for companies who are afraid of a bad reputation due to their software behaving in that way. So there's a lot of effort doing that, but it's not fully controlled at the moment as far as I know.
Thank you very much.